All right. All right. So we are all aware of Google Maps, but what I've always found challenging and annoying is that Google Maps just sort of takes you to the place, your destination, let's say a mall, and then just leaves you there. And you have to find your own way inside a mall, which is really annoying because it takes a long time. And by the time you're done finding a store, you don't have time to shop anymore. Um, so that's why we decided to go and create this, find a solution to this challenge. Our approach, we have decided to create a model that makes navigation in a mall easier for shoppers. So there are two parts to this model. Um, the first part is just making a map of the mall using graphs, right? So each store, each restroom, each elevator, each escalator is going to be a node in the graph. And the edges connecting the nodes would have a weight value associated with it. We're going to talk about what it is in a minute. So why do we even need a weight value to begin with? Because malls, they don't always look the same, right? You go in a mall, it looks one way the first day, and the next day you go, it looks different because there might be stores where you go in undergoing renovations and stuff. There might be roadblocks because of cleaning, or there just might be just way too much crowd the next day. So that's gonna change the whole problem. That's not gonna be the same for a shopper who went the first day and a shopper who goes for the second day. So this is why we need to take a dynamic approach to this problem. And this is done by changing this weight value each edge is associated with. Um, how we, why we would do that is because a higher weight value means that that specific path is more difficult to navigate. And this could be the case when the path is either crowded or is just hard to navigate. Um, so if the path is crowded, it would have a higher weight value, which means that shoppers should not take that path and consider a different path. Or the the weight value might also be higher if if the path is a staircase and there's an escalator or elevator available to you to take. Obviously, a staircase is more physically demanding, so it's going to have a higher weight value. So that's also going to change the weight value. Now, we thought about doing this by taking real-time feedback. Real-time feedback is really necessary because a mall doesn't always look the same as changing. And this could be done by just prompting our users who, in this case, are shoppers in a mall, the kind of the same way Google Maps does. Um, when you just go to a new place, it asks you for feedback on how the place was. We're gonna ask shoppers on how their experience was, and also if the path that they just navigated was crowded or not, or if they came across any roadblocks. And so this is all going to change the weight value in real time, which is gonna make our map dynamic. This is one way we thought a person would prefer navigation in a map to make it a lot easier than what it is now.
So we this is what we have so far. We implemented Dijkstra's algorithm so that when we here's the data slash example. So that when so let's just say we want to go from store 1 to which is on the first floor on this map to store 6, which is on the second floor. One thing we did add was if you have mobility concerns and you can't use stairs or escalators, we added so that you could only consider routes with elevators. So like here's with just escalators. If we do that same, um, run it again, you'll see that if we say that we need an elevator instead, it'll instead route us through the elevator. And so what we would probably do next was, try to incorporate real-time feedback into it. Obviously, we didn't have enough time, so if we had more time, that's what we would do next. So thank you so much, and thank you for offering this challenge to us.